Good afternoon, and thank you for joining today's webinar. Today, we will be discussing hybrid cloud management and how RackWare can help your organization protect applications, move applications, and manage applications in the cloud. Presenting today is Todd Matters, CTO and one of RackWare's founders, as well as myself, Stacy Piper, Sales Director for Public Sector. Please feel free to ask questions via the message box during the webinar. We will answer these at the end, and if we do not have enough time to answer all the questions, we will personally get back to you in an email. Here is our agenda for today's discussion. First, a few housekeeping items. Everyone is placed on mute during the call. We will open the call up for questions at the end of the presentation, or as mentioned, continue to take questions via the message box during the webinar itself. Also, please note this session is being recorded. So for those of you who are not as familiar with RackWare, I will give you a quick overview. RackWare provides solutions that help enterprises and large organizations protect application workloads, move workloads, and manage those workloads in any cloud environment. We've been providing cloud services for over 6 years to some of the largest companies and organizations across the globe, including public sector. RackWare is uniquely technology agnostic. We support all Linux and Windows-based applications, virtualized or on physical servers. We support all cloud providers and virtually all hypervisors. So Todd, as you have some insight into the use cases for the customers referenced here on the slide, would you mind walking us through a few of those today for the attendees?
Sure. So a couple of interests. The first is St. John's University. So that was an interesting one because they had a large number of databases running on physical servers. Some of the databases needed to go to other physical servers, and some were actually going to virtual servers in a cloud environment. The recovery point objective was rather aggressive, and we were able to accomplish that with the software. Another one is the Gift of Life donor program. The Gift of Life donor program, they also had a very large database. It's about 8 terabytes. Interestingly enough, about 100 gigabytes of the data was very, very important with a very aggressive RPO. The rest of the data, they wanted protection, but the RPO was a lot less aggressive. Also importantly, they didn't want to clog up their WAN link during their peak periods. So what we were able to do is create 2 policies, one for the 100 gigabytes at a more aggressive RPO, and a second policy to sync the rest of the database about 2 o'clock in the morning during off-peak hours. So there we were able to protect all the data. We were able to protect the higher priority data at a more frequent rate with a separate policy.
Perfect, fantastic. Thank you so much for that, Todd. On an interesting note, about 36% of CIOs in the public sector don't have plans to migrate to the cloud. In contrast to other verticals where almost 100% have plans to do so, but still have close to 40% of legacy applications they feel are not right for the cloud. Much of the challenge lies in the lack of knowledge and skills to make the transition even, though it is recognized the tremendous savings in labor and infrastructure in cloud providers. Some other inhibitors actually fall under the lack of a knowledge umbrella, for instance, security and data compliance. It's been proven that cloud computing environments are far safer than physical data centers. Also, there are several good solutions to manage and provide compliance reporting in the cloud, providing in most cases a more robust path for data and security compliance. Higher education is seeing an increased adoption rate of the cloud. Many see it as a competitive advantage, especially supporting alumni, athletics, and admissions recruiting, and other fundraising activities and initiatives. Perhaps the most compelling aspect is the ability for individuals and departments to streamline the IT constraints, getting research and projects started quickly. Those on campus concerned with the financial aspects see the cloud as a flexible resource and reducing the need to have idle resources consuming precious working capital. So in a recent survey done by CAO Magazine, 4 areas of focus were identified as those to pay attention to during the cloud adoption process, one of which being technology. There are complex issues about how to integrate the cloud and legacy environments at different levels of the technology stack and cloud services. IT must adapt and put in place the necessary tools to manage the new hybrid environment. Another, for instance, is people. IT will move toward a more agile approach as cloud is adopted, and some staff will lack experience consuming and operating technology as a service. The CIO needs to transform their existing capabilities and operating model to enable an agile approach by bringing the application and infrastructure closer. A third area was process. So IT organizations need to adopt cloud processes. IT needs to be able to move workloads from one service provider to another to take advantage of price evolutions and adjust the capacity to the demand on a continuous basis. And finally, engage. IT needs to be able to communicate with the business about how the cloud can support their needs. The CIO needs to demonstrate and drive value from the cloud. Additionally, with all the organization's entities, CIOs need to ensure IT is influencing and preparing for the transformations. So RackWare works at the operating system level. This allows us to support physical and virtual applications in data centers and any cloud. There's a secondary benefit for the IT department. We provide a single solution where multiple tools have been needed in the past. Our solution automates many time-consuming tasks, improving a compression of 20-to-1 in task-like application migrations. Policy engines drive consistency and cost management. Repeated tasks are automated and perform the same each time, reducing human errors. Disaster recovery synchronization and provisioning policies help balance RPO and RTO against cost. Governance policies ensure cloud resources are available to application owners and meet approved application standards and budgets. Automated tasks, self-service portal, and a single platform for all of your cloud management needs simplifies and reduces overall cost for IT. As you move more of your businesses into the cloud with end users building applications and assembling their own workloads, tighter governance needs to be in place. RackWare lets you control what golden templates are available, ensuring applications are developed on approved, hardened platforms. Budgeting controls, including metering, billing, auditing, and reporting, ensure IT costs are maintained. So Todd, at this point, why don't I hand this over to you and you can walk us through the technology.
Sure. So you can see that there's a number of use cases for the software. However, the underpinning technology for all of those use cases is a replication technology. It is a true any-to-any replication technology. So first of all, if you look at this picture, and on the left-hand side, there's 2 data centers. The technology actually works data center to data center. We usually talk about cloud, but data center to data center is actually still an important confluence. The software supports physical servers on the origin side as well as the target, and that's supported across disparate hardware. So for example, we could replicate from an HP server to a Dell server. Those confluences also support all the different hypervisor types: Oracle VM, VMware, Hyper-V, KVM. So for example, the software could replicate from VMware to Zen, which is a popular underlying hypervisor for many clouds, or maybe from VMware to Hyper-V, or for that matter, Hyper-V back to KVM, maybe if you're running a private cloud or something like that. Of course, the software can replicate from data center to cloud, but also increasingly an important capability is cloud to cloud. Whether companies are diversifying, maybe standardizing on 2 or 3 different public service providers, or perhaps they're running production in one cloud and wish to do disaster recovery to another cloud. And of course, as things change over time, we may see migrations from cloud to cloud as companies get perhaps a better deal with a different provider after a couple years stint with somebody else. An important confluence that's often forgotten about, in particular for a disaster recovery use case, is being able to replicate from cloud back to data center. This can be particularly difficult for some competitors because first, sometimes you may be going from virtual back to physical, but in addition to that, there may be many different hypervisor types, and there's no ability to utilize service provider utilities or services to do that. RackWare supports all of these confluences with its native technology, providing a wide range of support for different clouds as well as hypervisors. Okay, so let's talk about what this looks like at the high level. So let's assume in this picture when we started, we had a set of servers on the left-hand side. However, on the right-hand side, we had an empty cloud. There was no RackWare RMM server. By the way, that's the name of the software, RackWare Management Module. And there were no servers or virtual machines in the target cloud environment. Installation is very easy. You spin up a virtual machine in the cloud environment. The software installs on a Red Hat or CentOS server. It only takes about 20 minutes to install the software. Importantly, on the origin side, you don't need to install anything. The software simply connects in over the network at the operating system level. It performs a discover operation. I'll talk about that a bit on the next slide. But it understands enough about the origin workloads to be able to replicate them to the target environment. Next, it does a capture. We call this an image capture technology. It's file-based. It's not block-based. The software isn't simply replicating over sectors from an origin to a target. This is completely non-disruptive to the origin side. You don't need to configure access to any hypervisors or any storage arrays. There's no storage replication. This is all using the RackWare native technology. After the servers are replicated to the target environment, you have the servers on the target side are identical to the origin with the exception of the device drivers and optionally networking. There's a number of networking options. So again, this is non-disruptive to the origin side. You're still up and running in your production on the origin side. Your application owners can come in, perform whatever testing that they need to do. And now another important capability is sync. The software has the ability to do a very efficient delta sync from the origin to the target side. So if this was a migration, you could do your final sync. Actually, you can do as many syncs as you want to. So you would do your final sync, do the cutover, and start running production on the target side. And then at the appropriate time, you could actually decommission the origin. So if you look at the flow, so first there's that discover operation. So let me tell you a little bit more about discover. There's actually 3 levels of discover. So the first is very basic discover, just enough to do, or I should say complete a replication. It understands information about the software and the hardware. The next level is around understanding application affinities and discovering other elements of the entire environment to facilitate wave planning. The third level is a deeper analysis looking at usage statistics over time, understanding the peaks and valleys, and the software can actually recommend a right sizing for a server in the target environment. So moving over to the capture, that's the technology where the software does a live capture non-disruptively of the origin server. It understands information, importantly, about the metadata. Now, that metadata is important. That's the information that has the touch points to the hardware. Now, remember, as we're replicating across these different environments, the hardware on the target environment is probably going to be different than the hardware on the origin. Now, it may be virtual hardware, but it's still hardware nonetheless. And an important aspect of that final assign process is it looks at the metadata, understands the underlying hardware on the target, and configures those touch points of the image to the hardware that allows it to boot and operate efficiently in that target environment. Okay, next slide. So the setup for disaster recovery is actually very similar to a migration. The initial replication actually is the same. The one big difference, though, is for the replication, after the replication is done, you can create a sophisticated sync or DR policy. That sync policy defines your RTO and RPO characteristics. The DR policy that it's combined with defines a number of parameters about how you would like to fail over during an actual failover event. There are a number of options here. So you do have the ability to do what we call dynamic provisioning. In dynamic provisioning, the software will capture the image, but it will not use any compute resources. It's not going to provision any server. The software supports a very aggressive RPO in this configuration. It's low cost. And then only in the event of a failover or a DR drill, then the software will provision the appropriate virtual machines, complete the replication process, and you can fail over. Now, while this is your lowest cost option, it's going to be your longest RTO because you have to account for the time it takes to provision the servers. To accommodate very aggressive RTOs, the software can pre-provision the servers and combine that as well with a very aggressive RPO. So it's not a one-size-fits-all. You can tune and tweak your RTO, RPO, and cost objectives to the different sets of servers and data sets with different sets of priorities. Of course, another important characteristic is the ability to fall back after the failover is done, and assuming that the origin side did not need to be rebuilt. If it did need to be rebuilt, the software just simply replicates back to the origin, as it does support replication from cloud back to origin. Okay, so with respect to advanced hybrid cloud management, so there's a whole management layer on top of the underlying image management capability. So first there's management oversight. So this involves being able to create and manage users, creating policies for users, creating pools of resources that can be spread across them. There's governance approval structures, audit trails for audits. There's metering for billing and a very sophisticated reporting mechanism. It is self-service, so there's really kind of multiple facets to the user interface. For the migration and disaster recovery, that's for more of an administrator perspective that really kind of understands the infrastructure and the guts of the environment. But for just regular users, there's a whole self-service portal, again, that can be monitored with administrative oversight to do provisioning, perhaps a DevOps use case or something like that. And the whole point here is that you need to manage your cloud resources very differently from the way that you would manage resources in your data center. If you manage your resources differently, cloud has the ability to create great economies, save you a lot of money, but you do have to manage them very differently. So there's a number of deployment options. There's a number of provisioning models that can be overlaid on deployment. There's also predictive cost models where you can look at a workload, understand its usage characteristics, and the software can predict what those costs would be across different provisioning and deployment models. Okay, so we talked about the administration and the oversight. If you look on the left-hand side, there's several important objects that could be managed. So the first is a RackWare discovery group. This is basically a tiered application with networking semantics. It doesn't necessarily have to be technically a tiered application, but just a set of servers with some interconnected set of networking characteristics. So that whole group can be provisioned and managed in and across multiple cloud environments. And you can also separate out some of those pieces. There's what we call a networking profile. So this might be a load balancer or an Active Directory domain controller or DNS or maybe firewall settings. And likewise, you can have just a generic group of servers. You can deploy those servers and apply different types of network profiles, to build out your own environment as you see fit. So again, if you look in the upper left-hand side, there's a very comprehensive model that has everything in it, the number of servers all working together with the appropriate networking to glue it all together. But you can also kind of have objects with all the individual pieces and pick and choose how you want to deploy things. Along the same lines, there are also very sophisticated workflows that you can put together, maybe an automated workflow that Monday morning rolls around. The software will auto-provision a set of servers, restore or rehydrate a set of build systems, build a set of binaries, then provision a bunch of QA servers, run through a set of automated QA, save all that off. That may end up taking multiple days, maybe from Monday to Wednesday. When all that's done, the software will store all that off, save off the image state, and then delete those resources, and then fire all this up again, come Monday morning. You can achieve dramatic cost savings this way. So you have the benefit of the automation to perform the work that you need to, but when you don't need those compute resources, the image state can be saved off using the RMM and those resources deleted. And then either manually at will, you click a button, or through a policy, they can end up being rehydrated.
Perfect, Todd. Thank you for walking us through that. So just as a quick recap, we obviously covered a fair amount of content in a short period here. First, we are focused on large institutions and enterprises and their complex data centers. Our approach is comprehensive, and solutions are built on a platform that extends features and functionality across the suite. Many critical business applications operate in complex environments such as Oracle RAC and SQL clusters. RackWare moves and manages in the cloud as simply as moving a web server. So RackWare is a proprietary cloud management platform that does not rely on other technologies for it to function. No VMDKs or hypervisor toolsets, no agents or disruptions to the origin. A few of the features our customers and partners are highlighting are the ability to provision in a DR or dev environment that meets the unique needs of that application. Be it a critical RTO or dynamic environment, you can choose. In your DR and dev environments, RackWare provides you the ability to vary your synchronization schedule at the file level, whether fine-tuning an application's RPO, managing network resources, or compiling application templates. It's in your control. The last thing I'd like to highlight is the ability to have RackWare monitor your cloud resources and apply auto-stop and auto-start policies to applications with variable compute times. Now we have some time to answer a few questions. Moderator, are we actually unmuting the phone lines, or are we taking questions from the chat box?
If you'd like to ask a question, please raise your hand and we will unmute you. I have some questions that are teed up already.
Perfect.
The first question is, physical servers, you are able to migrate those into the cloud. How do you do that?
Yeah, sure. So yes, the software does support physical servers. I guess the secret is that it treats all servers as though they were physical servers, even if they're virtual. To the software, the only difference between a physical server and a virtual server is it has a different set of device drivers. So actually, by focusing on replicating workloads through that mechanism, the hypervisors, the reason we can support so many hypervisors kind of for free is because we can use the same methodology. Again, just manipulating the touch points of the hardware, understanding the device drivers that need to be injected and configured, and again, we use our own technology across these clouds. We're not using the individual, utilities and services from the cloud providers. They all have idiosyncrasies and deficiencies. So that's how we provide such consistent and consistency and versatility across all these different environments.
You talked about, next question, sorry. You talked about being able to handle databases like Oracle RAC and SQL clusters. Those are challenging. How do you handle those?
So the vast majority of databases are supported through the RackWare mechanism. The reason is the software uses a snapshotting technology. It never touches a live file system. So the software takes a snapshot. We support many different volume managers, and the replication of the sync is always done from that snapshot. Now, I should point out this is a customized sync, so we're not using anything off the shelf, so it does need to be very efficient. So the other advantage there, and the reason why we can support databases, is because with that methodology, you almost always end up with a transaction consistent image on the target side. So if you look at, an approach where you would just be blindly copying over sectors on a disk, there's really no way of knowing where you are in the middle of a transaction, especially if there's multiple applications running on that server. And that's why very many times you're with a competitive solution, you do a boot and the image appears to be corrupted, and you have to go back and try different points in time for the boot. So, again, with our approach, you almost always get that transaction consistent image, and that's the reason why we can support databases.
I have another question. What do I need in my data center? Do I need a cloud gateway or install anything?
So that's a good question. So no, you don't need a gateway. You don't need to install any virtual appliance or hardware appliance for that matter. You do need to configure access to the RMM at the operating system level. Again, because it views the environment through the eyes of the operating system, and as long as you make that operating system work in the target environment, you have the equivalency that you need. So the software does not touch the MDKs, it doesn't touch hypervisors in any way, or storage arrays. So again, you do need to configure networking connectivity and access at the operating system level, and that's all there is.
I have one last question, unless there are still some of the viewers that would like to ask a question. The last question I have is, you talked about application affinity. What do you mean by that?
So application affinity is basically the applications that work together and how they work together. So this is really part of wave planning. So if you have a project, you could have 1,000 servers or multi-thousand servers, or for that matter, even if it's just 50, and you want to, you can't, it's not practical necessarily to migrate all 1,000 servers at one time, or even all 50 servers at one time, but you do want to do things in cohesive chunks of applications, maybe servers, 10, 20, 30, or 40 at a time. And the software, the RMM, has the ability to go in as part of its discover process, understand enough about how those servers are talking to each other. It will create data sets and provide information. Actually, it'll do wave planning for you, based on some of that parameters.
And that looks like it concludes all of our questions. This webinar has been recorded and will be available to you to rewatch or share with your constituents. And thank you very much for joining RackWare today.